Hey guys, in today's video I'm going to be taking you through the topics on arithmetic sequences and arithmetic series in the A-level syllabus. Okay, so the first thing that we're going to talk about is arithmetic sequences. Basically, in an arithmetic sequence, the difference between consecutive terms is constant, such as this example we've got here that goes 5, 7, 9, 11, 13, and each time it increases by 2. Now there is a formula for the nth term of an arithmetic sequence, and it is un equals a plus n minus 1 times d. Un, as I've got written up here, is the nth term, a is the first term, and d is the common difference. They're pretty easy to understand, so I've only got one example here to actually show you. So the question is, the first term of an arithmetic sequence is 15, the fourth term is 33, find the common difference. So the first thing you want to do is write down that equation, un equals a plus n minus 1 times d. The question wants to know what the common difference is, so we want to be able to find d. So we have the first term here, which is 15, so a is 15, and the fourth term is 33, so that means that when n is 4, then un is 33. So we can put that all into our equation, and we get 33 equals 15, add 4 minus 1, which is 3, times d, and then we just solve for d. So subtract 15 from both sides, and you get 18 equals 3d, and then divide both sides by 3, and you get 6 equals d. And so the common difference is 6. And questions on this topic in the exam don't really get much more complicated than that. All you have to do is be able to understand this formula that I've got highlighted here. We now have some questions on arithmetic series. So an arithmetic series is the sum of the terms of an arithmetic sequence. So we've got the sequence that we had before, 5, 7, 9, 11, 13, but instead of just having the numbers, we're adding them together each time. And there are two different formulas for the sum of the first n terms of an arithmetic series, which I have both written down here. This first one, sum to n, of n over 2 brackets a plus l, you can use that if you have the first term here, a, and the last term, but no common difference. Whereas the second formula that we've got here, sum to n equals n over 2 brackets 2a plus n minus 1d, means that you only need the first term and the common difference, but also to know what the value of n is. So I've got two different examples here, one using each of these formulas. So the first one, we've got find the sum of the following series, 5, add 7, add 9, etc, 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 all the way up to add 75. So that means we've got the last term, 75, and the first term, but we don't have value for n. So that is another thing that we need to do first. So, because we know the last term, we can use our nth term formula from the arithmetic sequences section. So we write that down, un equals a plus n minus 1 b. We know that a is 5, l is 75, the common difference is 2, and we're finding what n is when un is 75. So we put that into the equation, 75 equals 5, add n minus 1 times 2, and then we can subtract 5 from both sides, we get 70 equals 2n minus 2, 72 equals 2n, and then divide both sides by 2, and we get 36 equals n. And now we have a value for n, we can put all of that into our first formula here for the sum of all of those terms. So Sn is 36 over 2 times 5 add 75. And we can simplify that down to 18 times 80, which is 1440, and that is our final answer. Okay, so the next one is slightly more complicated, and we're going to be using our other formula here. So the question is, how many terms are required to make the given answer? So we have this sequence, 5, add 8, add 11, add 14, and apparently any number of these will add up to 670. And we need to find out how many exactly do that. So the first thing we want to do is put what we know into an equation. So we get 670 is equal to, and we want to work out what n is. So we've got n over 2 there, 2a is 10, add n minus 1, and the difference is 3. And all we need to do is work out what n is. So we need to solve this equation for n. So multiply both sides by 2 to get rid of that 2 there, and we get 1340 is equal to n, and then we can just expand the brackets on the inside. And then simplify that, 1340 is equal to n, 3n, add 7, and then we can expand those brackets to get 1340 is equal to 3n squared add 7n. Put it all onto one side, 3n squared add 7n minus 1340 is equal to 0. And then we have this quadratic equation that we can then solve. So it doesn't look like it's going to factorise very easily. If you have a ClassWiz calculator, then there is a setting where you can simply plug in the numbers and it will find the answer. But if you don't, I'm going to do it using the quadratic formula, which is minus b plus or minus the square root of b squared minus 4ac all over 2a. So we get minus 7 plus or minus root 49 minus 4 times 3 times negative 1340 all over 6, which simplifies down to minus 7 plus or minus the square root of 16,129 all over 6, which gives us two answers, one being 20 and the other one being negative 22.3 recurring. However, as you can see, you can't have negative terms of a sequence adding up to make that. So what we're going to do is get rid of that answer, and our final answer is 20. So the number of terms required to make the given answer of 670 is 20. So if you enjoyed that video, then leave a like. If you found it helpful, leave a like. Any topics you want me to discuss, put down in the comments below, and be sure to subscribe for more maths related content.